The sun is the source of all our existence. Without the sun, no form of life would exist on our planet. In our expansion across the Earth, we have adapted to the environment and the changing climate that has provided us with our star king. We have worshipped the sun since ancient times, and we still do not take advantage of all its energy. Our life and everything that exists on Earth depends on that prodigious star that continually transforms. This leads me to think, what will happen to our sun in the future, and what will happen to humanity when that happens? If we do not self-destruct before or we are destroyed by some natural catastrophe, the fate of our sun and planets is surprising. Perhaps the ending that awaits us is not what you had imagined. Get ready, because today you are going to learn about the most surprising events in the past and future of the sun predicted by science. And with logic and common sense, we will know what will happen to our civilization when that happens. These and other questions are what make me think at night. It is when I fall asleep and move to the ship of thought. This ship can go anywhere in time and space. I am accompanied by more than 1.5 million people who interact with others through avatars. From Earth's orbit we see the sun serene and calm, as if it were always to remain in that state. A great lighthouse that gives life to our planet and keeps water in a liquid state. However, if we get a little closer, the sun is a gigantic ball of plasma that presides over the solar system. This wild power is what gives us life and is located about 8.5 light minutes from us. At the ideal distance, and whose evolution has been stable enough to allow life on Earth. But this was not always the case. What you are going to witness from now on is something amazing and at the same time terrifying. We go back in our time machine to 5 billion years in the past. Before our eyes, our solar system has not formed. Instead, we see a giant molecular cloud, a large mass of hydrogen that extends into the borders of interstellar space. Several light years away, a dying star, similar to what we know today as Betelgeuse, is on the brink of explosion. We have arrived too early. We must go a little further, until the massive star explodes and its shock waves interact with the molecular cloud. The great nebula begins to rotate, concentrating a large amount of matter in its center, until it begins nuclear fusions, releasing a large amount of energy. When such an amount of matter accumulates in a small space, the temperature and pressure increase, until a protostar is formed that continues to accumulate material and grow. We are witnessing the birth of the sun. The amount of material appears to be sufficient to form a yellow dwarf. There is a large amount of hydrogen, helium and other heavy elements to a lesser extent. The protostar continues to accumulate material and grow in size. When the temperature and pressure in its core reach high enough levels, nuclear fusion of hydrogen into helium begins in the core of the star. This is dangerous. We are in an area with a large amount of dust and gas. The disks of material that surround the sun conserve the angular momentum of the nebula that originated it. It is incredibly beautiful. These disks of material were joined together by gravity, forming the planets we know today 4.6 billion years ago. And get this, a giant planet, Jupiter, is the first planet to form in an orbit close to the sun, and then Saturn. We now know that these giants accumulated large amounts of material from the sun's disk that was surrounded by hydrogen and helium, and migrated outward. A large accumulation of material in this area is forming other giant planets in the outer region of the young sun, beyond the orbit of Jupiter and Saturn. In this region, temperatures are low enough to form Uranus and Neptune. However, there are other heavier elements that are forming the rocky planets we know today: Mercury, Venus, Earth, Mars, and other smaller bodies. This is how the solar system began its journey 4.5 billion years ago. In a beautiful cosmic dance, the planets were exchanging positions, and for billions of years, subjected to chaos and impacts, these are the remains of the solar nebula that formed our beautiful planet. The young sun is 30% less bright than at present, and its great stability has led to the appearance of life on the third planet. A cosmic miracle. At first microbes, then plants, animals and conscious beings like us who asked themselves, what was that bright light that provided them with heat? Many times we have wondered what the sun really was, until we discovered that it was just another star, like those seen in the sky in the darkness of the night. The difference is that the sun is much closer, but this prodigious star will not last forever. Just like life, it will undergo tremendous transformations in the future. The Sun burns 600 million tons of hydrogen into helium every second. This means it has a limit until the fuel runs out. However, the big question is, when and how will the Sun die? We accelerate our time machine and realize that the Sun is becoming increasingly brighter, and at the same time the Earth is becoming increasingly uninhabitable and forces humanity to look for other places to live. We contemplate the ephemeral dance of humanity, a species that emerges and moves like ants in an accelerated frenzy. In search of horizons beyond our earthly home, we have undertaken the colonization of the solar system and beyond, facing the astonishing diversity of worlds that require us to adapt to environments so different from Earth. As interplanetary explorers, we embark on an odyssey that takes us on journeys through inhospitable atmospheres and alien landscapes. Each planet becomes a challenge that demands ingenuity and resistance, forging a story of adaptation and evolution in real time. We look back and our ancestors contemplate the ancient land, remembering a paradise that they mistreated, until they understood its immense value. However, in that moment of revelation, the opportunity vanished and awareness came too late. As our spaceships dissolve into the vastness of space, we witness the continued evolution of our parent star. The Sun, that incandescent titan, increases its brightness by 1% every 100 million years, while its mass slowly fades. On the cosmic scale, this time lapse is just a cosmic sigh. On Earth, everything we are as humanity has disappeared, including our spaceships disintegrated and with elements joined together and scattered throughout space. Our planet remains nothing more than a vague, distant memory. But if we have had some contact with other beings, possibly someone will remind us of what we were. Earth's oceans are gradually drying up due to gradual warming, up to 1 billion years in the future. The first thing that became extinct was complex life, then plants and animals. By that date, the Earth will look like Venus, with an atmosphere of carbon dioxide, nitrogen and argon, and a temperature of 200 degrees Celsius. Only microbial life will remain. We do not see even a ruin, nothing of what humanity once was, not a memory, and all those people who longed to conquer lands and exploit everyone have disappeared forever. There is a great sadness in my soul that leads me to remember the beautiful people I met, great friends, family, artists and scientists. The large number of extinct animals, fauna and flora. Nothing lasts forever. We were wrong. Everything will be over long before the death of the Sun. Life on Earth lasted about 5.5 billion years. That's practically half the life expectancy of the Sun. We see with amazement that the habitable zone has moved to Mars. The red planet has been a desert for billions of years, but now liquid water is returning to its surface. Who knows if any form of life can thrive in that environment? We accelerate our time machine and see that the Sun continues to increase its luminosity and size. 4.5 billion years in the future, the Sun continues to expand and lose mass. This causes some of the planet's orbits to be altered. Earth's orbit will have expanded by a maximum of 1.5 astronomical units, but still, it's a scorching inferno. 5 billion years into the future, and the hydrostatic balance between gravity and pressure is broken, causing the ancient Sun to contract, increasing its density and temperature. Our star only has to fuse the hydrogen in its core to stay alive, and in a desperate attempt it expands, becoming at first an orange subgiant, and then a red giant. This desperate attempt causes it to swallow Mercury and Venus, also increasing its luminosity 1,000 times. But many things are going to happen here. The red giant phase lasts about 3,000 million years, and during that time the habitable zone moves between Jupiter and Saturn. Some satellites of Jupiter and Saturn will be habitable. Europa, one of Jupiter's moons, becomes a water world due to warming. Ganymede now looks like a habitable world for life to thrive. 3 billion years may be enough for the evolution of complex life. And look at this, Enceladus has seized and Titan completely changes its atmosphere. It is incredible how the transformation of the Sun can give other stars the opportunity to become more habitable. We accelerate our time machine to 7.9 billion years. The Sun no longer has hydrogen left to fuse, only helium remains. The essence of hydrogen, the fuel that gave it balance for once, is no longer available. What remains is the helium, and in an act of heartbreaking agony, the Sun undergoes a desperate transformation. The temperature shoots up to 100 million degrees and its radius expands to 200 times its original size. In this last attempt to maintain its stability, the remaining helium fuses to give rise to carbon and oxygen, prolonging the agony of the stellar colossus. It is incredible how desperately the Sun tries to remain stable, and how its attempts only prolong its agony as if it were a living being that does not want to die. When helium is depleted, its mass will be insufficient to fuse carbon. The Sun is shedding more and more of its envelope, until it forms a beautiful planetary nebula, a state that will last several thousand years. Despite its slow agony, the death of the Sun will be spectacular and beautiful. Will illuminate the skies of planets several hundred light years away. No one can think that a long time ago, in that planetary nebula there lived a civilization that tried to expand and search for other beings in the universe. The solar system will end as it began, in a nebula, but at its center shines a white dwarf with half the mass of the Sun. In our time machine, we see how the nebula will dissipate in about 10,000 years, but there will still be the little one compacted core of the Sun converted into a white dwarf, with a temperature of 29,700 degrees Celsius. However, this brilliant white dwarf will diminish in brightness over billions of years, until it becomes a black dwarf. This is how our solar system and all traces of the human species will end as if we had never existed. We return to our present time, to our beautiful planet Earth. We have seen the chaos, birth and destruction of worlds, which teaches us a great truth about the cosmos. Any time, whether good or bad, it is temporary. The universe has lent us its energy, and no matter what we do, we will die and transform like the Sun. Living this moment is special. Surely we will not live to see the death of the Sun, and if we do, evolution will have turned us into something else, which is certain that nothing will remain of us, either on Earth nor in a billion worlds. The great cosmic machinery forces us to change just like the stars. We are the result of 13.7 billion years of evolution, and each moment of existence prepares the ground for future generations. We live an ephemeral dream of existence that seems to last until eternity. When you look at the sky tonight, remember the stars. We are precious and wonderful beings of light, composed of elements of stars and other events of the universe. One day we will have to return to the cosmos the energy it lent us so that others have their opportunity. Hush.